Hello, class. How y'all doing?
Good, Professor. How are you?
All right, everybody sign the room.
Yes, sir.
Yes, sir.
Okay. Everybody got a question about my assignment? I graded the first one. I left the second one open for you to hopefully try to get that one done right. And like I said, you're supposed to turn in two files. Submit two files: the .h file and the .cpp file.
Yeah, I did that this morning. I believe I did it right.
Okay. Yeah. Because I went over. Let's see. I'm gonna pull up visual right quick. I'll just pull up this program. I think this one, which one of y'all had. All right. So what happens is it comes up. Oh, I need to share my screen. Let's see. Share. Oh, am I sharing it already? Okay. All right. So this was one of the programs. I don't know who wrote it, but I'll just take this program. Next month. All right. So this is the Visual Studio window. Normally you would type this program up. Now I have a header file, but I'll just create another one. See, this person, they didn't even include the header file or the call for the header file and even the function from the header file. But I'll go ahead on and do it right quick. So normally what you would do is, I think I had it in the how-to files. You can either right click on any one of these links here, but like say you could right click on header files and do add new. It's still gonna bring up the same menu here, but you choose header file and then you could give it a name. I'll just say what's going on? There we go. I'll just say in class.h. All right. And so I'll add it. And so now all of a sudden I got a in class.h file. So now I can go in and do the pound include. That's spelled wrong. I was stream at least pound include. Well, include, not pound include. Using namespace std, and then you cannot. Somebody did that too. You cannot use main. Main can only be used one time and in the source file. It don't have to be called source, but the file where you're writing your main code at only one main file, and it has to be called main. So I'll just do void, and I'll say heading, no arguments. All right. So I have this function, the header function I'm creating, and I could do something like cout, and I'll do 1, 2, 3, and I'll do another one, then tab. Okay, in class. And then I'll just do this. And I'm just doing this so you can see. All right. So I have my header function my header file created. Once you create the header file, you can go back to your source file. And now you can replace this with what it was in class.h and enclosed in the double quotes. All right. So you do that, but now all that did was give me access to everything that was in the in-class.h file. If I wanted to, because I could have multiple functions in here. Like I said, a header function, another function, a body function, a footer function, or whatever function. So I can have them all in here, but in order for me to access them, I have to have this file loaded. Once I do that, then I can call any function that I want from this file because it's a part of this one, being that I loaded this. So now I could go here and I can say what I called it head. See, I gotta remember the name. Heading. I called it heading. So all I do is heading not that, with no arguments, semicolon. That will call that function will put those 4 lines, type out in class header function call, and then no and 4 more lines. So let's run this. Okay. So I'll do the build because in class it's gonna tell me whether or not I have errors. Succeeded. All right. So I can do the debug and here. So now you should see the output. Notice the 4 lines, and then it called that header function and what? In class header function. So it called it, printed the other 4 lines, and then it executed the program that was in the main function. So I could put in my numbers. I could put in 95, 95, 99. Okay. And took off some people didn't put space between a space between here. You know, some people didn't put a space between this. Your average is, certain little things they didn't do to make it readable. Make sure your output is readable. All right. And that's basically how you would have were to do the program. All right. So that's it. You write, you create your header function, you include your header file, and then you call the header function. All right. So that's basically it. Let's go back to. Let me go to. I want to get to this. We're going to complete the chapter. Where in here? Okay. We're going to complete the chapter. I post the test. The test will be open at 2:00. All right. From 2:00 today until Monday, February 1st at 12:59, not 12, 11:59 p.m. All right. So you got all of this week and up until Monday to take the test. All right. I also will publish the Solo Learn. Solo Learn is it's something that interactive online, and you could get to it just typing in Solo Learn or go to the SYL site of our web page, and you'll see the Solo Learn to the right. I think you could just type Solo Learn. I don't know if it's .com, but right. So you could sign in. I mean, you can create a login. I think I have a sign in. I'll show you. I'll just use my Google sign in because I don't know the other one. What happened? Okay. All right. So I'm in, and that fire come. Okay, that fire. So I'm in. Then I could go to the courses, and what it is, I got it to where you can do the C. I want you to do C++, and then there's modules. All right. So you go through these modules and see them. I went through most of those for the class, showing the class how it's done. All right. So this is the first. Where's the first one? Oh, this is the first one. Basic concepts. And I want you to go through each one of these phases. All right. Just go through the process. Hopefully you'll read through it and understand what's going on, general purpose. It just giving you information on everything. It's like I'm taking the test. I want to take the test. C++ is just okay, make it client. Okay. All right. I don't want to take the test though. Because you go in and still new lines, but this is unless they changed it. But anyway, it tells you the see out object does does not insert a new a line break at the end of the output. All right. One way to print two lines is to use the NL manipulator. So see, it just introducing you to the NL command. So when you start writing your code, I tell you to space down so many lines after whatever. You know that you can use the NL and use it in this fashion. It tells you can try it, So here's the code. And what I could do, I could put multiple NLs wherever I want to. I could run the code, but I could do L. And all I did was added two more lines to it. And then I should be able to run it, try it. I want to exit. Okay, run it. And it's going to give me the output here. And it should give me those. See, so it give me what? I was here, it went one, then it went two, then it went to the third one, print out our love program. All right. So it'll take you through those things so you can get familiar with coding. So it won't be so foreign to you when you when I give the assignments. All right. And like I said, it's for credit, it's for points. So just go through it. I think it's doing that to me because I done been through it. But it normally takes you through it, asks you questions and whatever as you go through it. Because if I go through, let me see if I got one that I did go through. Yeah. So yes.
I had a quick question in regards to like how it's graded. Like you said, it's
On
taking
this?
points. Yeah. So
No, this is only graded by if you saw. Well, I'll show you. Let me go to it. When you click here, or when I click here, you're gonna have your modules in there, and you'll be able to look at the report here, and it shows that all of these are completed. You
okay.
understand?
Yeah,
Right.
I got you. Okay,
Right.
I got you.
So it's not where, I did it, I messed up on that one, so what's my score? No. You just going through the motions of going to practice it. All right.
Okay, yeah, I got you.
Right. So hopefully it'll help you better, better program. All right.
Yes, sir.
Okay.
So you mean it's graded as in like it's on their website graded? That's what you mean, right?
Well, it's graded as if you just you went into it and you completed the module.
You did it.
Yeah,
Gotcha.
you did. You did. Oh, I messed up on that one. Oh, I didn't get that one right. Oh, no. Just doing. Because what? Even though you may have gotten something wrong, you went back and fixed it.
You learn it.
Right. Yeah, you learn.
Yeah.
There you go.
Literally, like, okay.
Right.
Thank you,
Just like the
Professor.
way I got you. I like it.
Right.
I've been using it all morning.
Huh? Oh, you've been using it? Okay. All right.
I don't know. It seems because it's a hands-on. It's easier.
Right. And it's like it introduces it to you slowly,
Yeah, slowly, step by step. Yeah.
Right. There you go. Yep. All right. And what I did, I post a test. The test will be there. And I post this quiz here. This normally just a quiz saying, "Oh, I've read the chapter." That goes to the bonus section. 5 points added each time. So, like I said, that just build on your points, which is just 5 points, but it can help you at the end of the semester. I got the quiz, the chapter quiz, which have like about 5 or 10 questions that gonna be on the test, but just quiz questions kind of get you into like, oh well, wait a minute, this is how the questions are asked. This is what questions they're asking, and so you kind of get an understanding of how the test is given. Then we're gonna talk about this in the chapter before we get to the end. Variable names, all right, and all this is a quiz where I give you variable names that, like, say you writing code, give you variable names. Let's go. I'll just go to the question. So look, it give you a variable name such as X, and it asks you, is X a valid variable name? All right. Then it gives you a variable name year to exclamation point. Is that a valid variable name? And all you have to, see what I'm saying? Then all you got to do is click on invalid or valid. You got what I'm saying? So, and we're gonna go over some of the rules for a valid variable, in before we get to the end of the chapter. So you can take this quiz. And then this gonna kind of enhance your knowledge of, oh, I could create variables this way. Oh, I don't have to just use it like this. Oh, I cannot use this. All right. And if you go through that, I think that what we just went solid solo learn, it might give you some tips too as to what variable names are and how they use. So that'll be available once at 2 o'clock. Most of this stuff at 2. I think the solo learn already made it available if I'm not mistaken. So let's get any other questions. Anybody have any other questions? Questions? All right. Where's the, hold on here. All right. So in the chapter, all right. So we talked about software. We talked about system software and application software. System software, you can categorize them into operating system software, utility software, and software development tools, all right? But then you have application software, which could be software that you buy specifically to do a specific task, like your video rendering software, your text editing software, your PowerPoint softwares. That's specific software that you use to do whatever. All right, like apps on a phone, that's applications. But if you got an Android is the operating system. You understand? So those type things. So different. Well, what is a program? And we kind of talked about that. A program is a series of statements that are in logical order that will perform a particular task. All right, that's all it is. Statements that are in logical order performing a particular task. And the book says a computer program is a set of instructions that tells the computer how to solve a problem, right? Or perform a task, right? And they are written in logical order. Okay. All right. Here's a list of things that the computer should do. The computer should be able to display messages. All right. It should wait for the user to input numbers. Well, this is a particular program they've written based on hours work. The hours work, get a message. How many hours did you get paid? How much do you get paid per hour? So this is like the pseudocode for a problem dealing with pay, like how many hours you work, what's your pay rate, and then it calculates it and then displays it. So that's all this is. That's just pseudocode for an hour's work. And the pseudocode or the step-by-step instructions we talked about, it's called your algorithm. Algorithm is just the steps that it takes to perform something. If somebody asking you, like say, different people might cook, or say barbecue a certain way. So if you ask one person, well, how do you barbecue? And they'll tell you the steps that they follow. That's their algorithm. It's not a program, but it's the algorithm. It's their step-by-step instructions. All right. So, and another person might say, well, I do it this way. My step, I move this step to step 5 rather than step 3, and then I perform it. But that's their algorithm. That's what they do to get their barbecue to be whatever it is, their end result. All right. But it's the actual algorithm. All right. And like I say, computers, no matter how you look at it, the computer only understands zeros and ones, nothing else. Zeros and ones. All the information that we put in the computer is converted to zeros and ones, no matter what it is, pictures, music, documents, whatever, zeros and ones. All right. You got to remember that. It takes it and converts it to zeros and ones. All right. So, and we're going to be writing programs using programming languages, programming language called C++. But we know that there are various programming languages out there. We're going to look at this program, but let me see if they talked about the different programming languages yet. Right. See here, we'll get to it whether they show the different programming languages. But what I want to do is want you to look at this program with me. Let me change this real quick so we can flow. All right, so it'll scroll up there. All right, so we look at this program. As I just said, all C++ programs must have a main function. So you cannot try to go and write a program and say, well, they use main, I'm gonna use begin. Wrong, it's gonna give you an error. It's looking for a main function. You got at least one main function. That's the function it's going to go to first. And then if you have other functions, which we'll get to toward the end of the chapter, end of the semester, how you can have other functions in your program. Even though we know if we look at this, we have in this function called, it's a header file called in class.h. We have a function right here, right? But it cannot be called main. If it's main, I'll get an error. And I'm gonna try. And I don't want to try it because every time I try something with this class, it looked like it worked, but it's not supposed to work. All right. See, let's see. Let me run it. Let me go ahead and run it in the source. And if I try to debug it, see, look, it give me the error. See, because it's looking at this main. And it's looking at this main, and it's like, okay, which one is the proper function? All right. But your main is always should start from your source file. All right. So now it has a conflict, all right, in here. And I could call this something else. I'll call this a class. Now they're two different files, but still the other function it's going to try to come back to this program. And header is in the other program, which is a header file. Heading is a header file. All right. So you're going to get an error. You cannot, your header file, your main function has to be in your source file, and you can't have but one. And like I said, that's very important. You got to remember that, because you lose sleep trying to figure out a problem. Deal with this type of situation. All right. So let's look at the program. The first statement here is a comment. / this program calculates the user's pay. No matter what you put after this / and that's forward slashes, it will not be anything dealing with the execution of the program. It's just a comment. Even if you put a valid statement, all right, I could go here and I can say, not here. I deleted it. I'll go here and I'll go to the top and I'll do / this is a sample program. All right. So why is this here? Heading. Oh, I know. No, that's right. And I'm just trying to get this error out. Oh, int. No, this is supposed to be heading. All right. So, and this is supposed to be man. All right. So now, anything, I can even put a valid statement here. I can say pound include. See what it's in green. It doesn't matter. Even though it's a valid statement, but this statement will not be executed because it's part of a comment. Anything following these / is a single line comment. Everything across is commented. All right. So you got to remember that. So that's that part. So let's look at the next line. The next line, pound include IO stream. I'm loading a header file that will allow me to use the cout statement and the cin statement to output and input information in my computer. All right. I can input using the CN or output using the Cout. Without this statement here, I will get an error. All right. That header file says, okay, now I want to use the CN or the Cout to do something in my program. All right. The using namespace std load standard libraries. Now, as I told you before, what happens, I'm gonna comment this out. If I comment this out, I'm gonna get errors on all of my Cout and CN statements. All right. What happens is, well, I didn't show errors. Oh, because it's in the other one. I'll comment this one out because it loads it once it actually pull it from here. All right. So watch when I go back. See, all of my Cout statements, my CN statements will not work now because I didn't load that standard library. But if I do that std : I fixed that problem. I should have fixed it. Yeah, it should have fixed that problem. And that's supposed to fix that problem so that I won't get that error. So you could do it either way. Either way is fine. It's something called programmer's preference. All right. However you code your programming style. Everybody gonna have their own style. How they create their variables. How many spaces they put in between certain things, where they put their open and close brackets and stuff like that. You know, you're going to create your own programming style eventually, or have your own programming style. So see here, on each one of these statements, I'll get an error because I did not use my standard library. All right. And that'll remove all the errors. Even so, I got this, no problem, because it's almost like doing it double. All right. But that's that. Now, let's look at the next statement. All right, the next thing, we got a blank line. Now, you can have 100 blank lines between this statement, between lines 3 and line 5. You can have 100 blank lines. Program won't give you an error. It's just going to skip down to the next executable line. So blank lines does not hurt your program, okay? Remember that. Blank line does not do anything to damage the integrity of your coding. All right, it's just the visibility of it. Now, here we go with the body of the main. Int main, no arguments. That's the actual main function. It starts with this open curly brace and it ends with this closed curly brace. So everything in between here is a part of the main function. So we have now, everybody see this, double, and then the word hours, comma, rate, comma, pay, semicolon. What they did here is said, okay, I'm writing this code. I want to introduce 3 variables. What are the name of the variables? Hours, rate, and pay. So I introduced these 3 variables, but I have to give them a data type. I have to tell the computer what type data these variables will hold. Double says I'm going to hold a value that has a decimal point, or I can hold a value that has a decimal point. If I put in a value that is a whole number, the system will just add the decimal point, 0.0, right? But double says I'm allowed to, or I can add a value with a decimal place in it. All right. So double, hours, rate, and pay. Now, the thing is, there are different data types that you can have in all programs. Double is for float data or data with decimal places. Float and double are the same data type, but double can hold a larger number than float. There's another data type called int, all right? Int holds integer data, which means data that is of a whole number, no decimal place, all right? So there's double, and float, which is of the same class, but one can hold a larger value. Then you have int, and then there's another part of int called short. So you can have a short int and you can have an int. Short int, can hold a larger number than short int. Okay, so we dealt with the decimal value using double or float, the int value using integer value using integer or short, and then we got character data. All right, you got char. Char deals with a single character. Okay, when you create a char variable, it allows you to define that single character. Now, later on in the chapters, we're gonna get to deal with arrays, where we can create a string of characters, all right, of a char variable that's an array of characters. And there's also a data type that's not pretty much in the compiler, but it is one called string. A string is a series of characters, all right? So you can have a char series of characters in an array, or you can have the string characters, all right? So you got int, double, you got int and short, which is of integer, double and float, which is of the decimal values, and then you got the char, but then you have, which is a single character, and string, which is multiple characters. All right. So that's what this is. This is just the data type, and these are variable names. Now, we got a quiz with variable names. What's the rules for variables? All right. When a programmer is to create variables, they have to follow certain rules. I'm gonna give you three of them, maybe four. Three of the rules are: one, the variable must be of one word, meaning the letters that the variable contain cannot have spaces in it. So if I wanted to create a variable called street address, I can create that variable, but I can't have no spaces anywhere in the word no space street and address. I could put an underscore. That's fine, because the underscore is not a space, right? So I could say street underscore address as valid. Street space address, that's invalid, because what? It must be of one word, no spaces. Number two, the second rule is a variable name cannot begin with a number, right? So what I'm saying is I cannot have a variable called name, all right? Well, I'll say int name, and then, or no, I'll say num. Int num, and then int num2, or no, int 2 num. No, can't do that. All right, it might be confused. I'm talking about this. I cannot do this. I can't say int num, and then, well, I'll just put like that, and then say int 2 num. All right. 2 num is an error, because what? The variable name that I'm trying to declare begins with a number or a digit. Okay. It cannot happen. Now, I can do this. Num2, perfectly fine. Or I could say N2 UM. That's fine, as long as the digit is not the first character. All right. So in class, these are some lifelong lessons of programming. All right. The naming of variables, you need to learn it, keep it, and as we move forward, that there, you shouldn't have to think on that. You should know, variable names, hey, this is the way, this is the way, this is the way. So because what happens is, if you don't learn it in this class, and you're always having to go back, then when you get to the next class, the teacher is expecting you to know this. Hey, write a program. I want the variable. My name tell you what variables. I want you to write a program to do X, Y, and Z. and you're doing the program and you putting variable names in there that's giving you errors, and then the teacher gonna ask, well, where did you learn your programming from? Because the rules for C++, you cannot do this, create these type variables, right? So that's number two. Number one, no spaces, must be one word. Number two, it cannot begin with a digit, a numerical digit. And three, it cannot have any special characters. No special characters nowhere in the name. And you say, okay, well, what is a special character? If you look at the top of your keyboard on your computer, all those exclamation points, those little carrots, the at, the pound, the dollar sign, percent, all that, all those are special characters. You cannot use them. Look at the bottom of the screen. Of the computer. The comma, the less than, greater than. That's used in the computer for something. The period, question mark, slash, double quote, single quote. All those, you cannot use those in your naming, even parentheses, curly braces, whatever. You cannot use those in your name scheme. All right. It got to be one word. Cannot begin with a number, and it must not have special characters. So that's the three rules. And one other rule you can add in there is you cannot use reserved words or keywords. Now you might say, well, Mr. Sylvester, what is a keyword or a reserved word? A reserved word or a keyword is any word within the compiler that already have meaning within that compiler. So if we look at this program here, int, so I know that I cannot use what? Int as a variable name, because what? Int is already understood as being a data type, okay? Looking at this, I can't use double as a variable name because double already have a what? Purpose within the compiler, all right? Look at this, cout. I cannot use cout because cout already have a purpose within the compiler. So what? Reserved words, I can't even use main. I can't create a variable called main. I can't create a variable called namespace. I can't create a variable called using. You know what I'm saying? I can't create a variable called include. I cannot do that. Those words are already have meaning within the compiler, and you run into all type of problems. Okay, so that's those are the rules for naming variables. You create your own variables. Now, they got there's something where they call it camel case. All right, and what that is if I create a variable called I'll say okay, metropolitan, all right? Valid, right? One word, no space, which is no spaces, doesn't begin with a number, and metropolitan is not a reserved word, all right? So then somebody might say, well, I'm in my programs, I'm gonna create a technique like this, okay? All right. So what they did was they call that camel case. In a sense, cap, lowercase, cap, lowercase, cap, lowercase. So what happens is that you capitalize the first lowercase or whatever, or vice versa, but it's just alternating uppercase and lowercase. Nothing is wrong with that. Okay. And then some people might choose that as a name scheme or which is a programming style. Right? Nothing is wrong with that. The only problem I tell you may have when you kind of like hooked on your programming style is if you ever become employed with a company that has certain guidelines for programming. All right. It's nothing to do with the program running, but it has everything to do with the company saying, trying to be uniform. All my variable names must be of this format, whether it's whatever, dash, whatever, or must be camel case or whatever, and when you're with a company, you have to do what they ask. So they might say, okay, when you're declaring your variables, all variables of the same data type, I want them all declared at the same time. All right. So all of a sudden, what your programming style has to go out the window. And not necessarily you have to just don't do it, because you always can code on your own, on the side. But at the same time, when you're with that company, you have to follow their protocols, because that's who paid you. All right. But otherwise, there's nothing wrong with having your own programming style, your own program style. Okay. So let's get back to here. So now in this program, all of a sudden now we see what? / again, right? That's a what? A comment. This is not executed. It's a comment is normally helpful, something put in the program to help the programmer or somebody who may come behind the programmer later on to understand what's going on within the program at that time, at that particular time. So if we look at here, / get the number of hours worked. So it's telling you this is what these two statements is involved with, getting the hours worked. So you have what? See out. Now see out, we said console out. So send or stream that text, which is enclosed, that string, which is enclosed in double quotes, stream that out to the console. So it's going to output how many hours did you work, ? Space, and then, it closed the double quote. But notice that space. Some of y'all don't be putting the space. Y'all put the double quote here. And so when the person have to type in the number of hours worked, it's right alongside of the ? And I tell you, I want it to be readable. Make sure your program is readable. So the next thing, or then let's say see out is streaming that. But then you got a CN. That CN pauses the system, and then it waits for you to input into hours or type in from the keyboard the value for hours. So once you type in a number for hours, you hit enter, and then the program going to continue. And then you have a comment, get the hourly pay rate, and then it's going to output see out. It's going to stream this to the console. See out, how much do you get paid per hour? ? Space. All right. So now then it waits, all right, for you to input the rate. Once you input the rate and hit enter, then it actually sends the value into rate. And then what? Comment, calculate pay rate. Now what? Whatever's in hours and whatever's in rate, multiply them together and store them into pay. All right. So this is an assignment statement. It multiply these two and then assigns it to pay. It gives the value, put the value in pay. All right. Then comment again, display the pay. And no matter what I put after that, hey, it's still a comment. But then the next line, see out, and you stream into the console out. And if you look at it, you have earned space $. All right. And then the double quote, and then stream pay, which would be the actual calculated value. All right. Then stream inline. So you're going to put an inline at the end. All right. So that's basically what this program does. All right. So hopefully you got an idea of how a program or what those statements are in the program and what they do, in the program, how it affects the program. All right. So programming languages, and we talked about it, You know, there's many different programming languages. The ones we use today are high-level languages. There are machine-level languages such as the assembler. All right, but it's hard to code in assembler, or harder to code in assembler, because you're dealing at a lower level. High-level language, you create those variables, it put them anywhere on the system that has available memory. You use them, and you go on about your business. Look, you gonna let this stop. Well, I'll tell you. So it might come to my phone. I'm gonna stop. All right. So, what I was saying, high level languages, you can write the code, bam, you're done. You know, because high level languages take less amount of lines to write than low level language. All right. So, but again, as we said, machine language is what? Zeros and ones. And the computer can only understand zeros and one. All right. And like I say, over time, like I say, they used to have there only were low level languages. And the person that ran the computers pretty much knew how to manage and operate the computer. They had to know addresses, whatever. Nowadays, you don't have to worry about that. You could pretty much teach a little kid coding, you know, and they could go in and code. But before, the person had to be so well in tune with the system that they was operating, you know, that it was hard for just anybody to just step in and try to do their task, do their job. So these are some of the newer languages that came out after the generations of computers start changing. Basic, Basic was a language. Basic, I think, at one time used to come with the MS DOS when you bought your computer, and that MS DOS, I think it had Basic in it. Fortran is more or less a scientific programming language. A lot of scientists use it because they can just write 4-5 statements and have the calculation. Boom, it's done. COBOL is more or less designed for business processing reports, whatever on a large scale. Pascal it looks somewhat like C++, but the coding is different. All right. But they're all languages. You can take each one of these languages and say, okay, I want to write a program to add 2 numbers. And they all can do it. But to say which one will do it in the least number of statements, that's when you run into issues. Or, saying like, because you don't want a person to have to know how to write 100 lines of code, whereas the other program takes 6 lines of code to accomplish the same task. So it's just the way people are. We designed to say quicker, faster, simplest. All right. C, C++, C#. Even though they're all in the same family, they too still have their own individual way of working. I think the C language. In C C++, we use C out. I think the C language, if you want to print something, you use the printf. So it's certain things that is the same, but it's a little bit different. All right. You got Java, all right, which is a course we teach. You take that toward the end of your curriculum. Java. Then you got JavaScript. JavaScript, I'm using JavaScript in my web pages to validate code. Sometimes you have JavaScript to maybe scroll text. You may have JavaScript that will have a slideshow within a web page. All kind of things like that. That's what your JavaScript does. You have Python. They're using Python in education now, and many other things. A lot of times they use them in the gaming. When they create these games, they use Python. Ruby, I've never really used Ruby. I've never used Ruby, but it's a programming language. And then you have the Visual Basic. Visual Basic comes from the basic program, but the Visual Basic now incorporates the windows. See, like a lot of times when you see those error messages from your Windows applications, they normally is that Visual Basic Code that actually generates that. All right. So these just are some of the programming languages that have been developed over the years. All right. And like I say, it just depends on what your style is, which one you successfully coding in, as to which one you're gonna stick to. All right, over time. But like if you get a job, you're probably going to use what's at the company. All right. So source code, object code, executable code. All right. You all have done this. All right. If you turn in your assignment, you all have done this. Your source code is what? The actual program that you typed up, right? That's the source. The object code is what you get when you actually compile it, all right? And they compile it and it says, oh, no errors. All right. Now, I don't have any errors, but it doesn't create an object, the object code to where now once you do the debug, all of a sudden it takes that code, get generated to machine language, and now you have your executable code. All right. So that's the process. And the source code is just the source file. That's all it's saying right now. All right. All right. Any questions so far? Questions? All right.
Yes, sir.
Okay. All right. And so this kind of shows you now. See here, G++. It's a compiler that's running on Linux systems. And to compile it, you would use the G++, and then they gave this command. This a parameter that they may use actually either to hide certain warnings or do whatever. I'm not sure, but the -O has a purpose. And then you got hello and then hello.cpp. All right. So that's a command that's generated. So I'd say, for example, Linux systems, on a Linux system, the following command called the C++ program name hello.cpp to be preprocessed or all compiled and linked. Okay. The executable code is stored in the file named hello. So what happened, it compiles hello.cpp and creates a new file. Well, not a new file. It takes that code, change it, and regenerates it for the machine language, and it creates a file called hello that you can just type the name in and it go execute. All right. You don't need a compiler then. You don't need a compiler to put it in and then run it. Once you compile it successfully, it creates an executable file. All right. That you can, it's a .exe file in a sense that you can run anytime independently of an operating system. All right. What is this environment? What is a program made of? Made of statements, all right? All right. There's a certain element that are common in all programs, all right? All programming languages have a few things in common, all right? And it says in table 2, lists of common elements you may find in most every programming, right, in every language. Keywords, when we talked about that, keywords are reserved words. Those are words that are used by the system and have special meaning. All right. You can't use those for variable names. All right. Programmer defined identifiers. Okay, that's your variables. Programmer, and it could be variables for file names, like say when you're doing read from a file, write into a file. It could be structures, classes. It could be the variables that you have in the program. All right, programmer defined identifiers or variables. All right, and what are the rules? No spaces, which is one word. Cannot begin with a number, and cannot have special characters in them. All right. Now, all programming languages have operators, okay? plus, minus, all right? Also, you have less than, greater than, equal to, not equal to, all right? All those different operators can be used in most programs, all right? Punctuation, all right? So what happens is the punctuation would be more or less the syntax, how you write a valid statement. Oh, all certain statements must have semicolon. You must begin such and such. So that's the punctuation. Okay, characters that mark the beginning and ending of statements. All right. Then the syntax, certain rules you follow. If I'm doing more than one variable, I got to separate by a comma. Just certain things that I have to do. Rules that are set. Just like reading English. English, if you ask a question, what goes at the end of the end of this? Well, I can't say it. End of the words, a question mark. If it's just something that's stated, it's a period. That's the rules. That's the syntax for writing in English. All right. Also, what subject verb agreement? There's a rule you got to follow. So in programming, you have rules and you got to follow them. All right. So you have to follow them. So basically, this is the exact same program. All right. That they had previously. All right. Calculate the pay. All right. Same thing, double this. Okay. So you're getting this, you're calculating the pay, and then you're displaying you have earned whatever pay. All right. So this basically is the same code. Right. A keyword, reserved words, as we said, are words that already have meaning within the system. All right. And all reserved words in C++ are lowercase. I don't care which command or word you're trying to use in C++. They all are lowercase. All right, remember that. They are lowercase. All right. The programmer defined variables in this program is what? Hours, rate, and pay. Okay. That's the programmer defined identifier. All right. So now, and they tell you that those were the words. Operators. Remember talking about equal sign, multiplication. All right. So this multiplies this and then assigns it to pay. All right. So they go ahead, and like I said, you got other operators within that too. Relational operators such as greater than, less than, greater than, equal to, less than or equal to, not equal to. All right. And we're gonna go over those that gonna come up later. All right. Now, certain statements have semicolons at the end and certain ones do not. You as a programmer will have to learn that and learn when to and not to. All right. Use a semicolon. Notice no semicolon after the pound include. No semicolon after int main. No semicolon after open curly brace. No semicolon after close curly brace. All right. So you're gonna over time learning how to code, you're gonna realize how to and where to put semicolons or whatnot. All right. You're just talking about the program. We talked about each line and what they do already. We talked about variables, and let's see if this is the way they have the rules. Variables. A variable is a named storage location in the computer's memory for holding a piece of information. And like I said, when you as a programmer create a variable in your program, you're telling the system, take this variable name, assign it an address in memory, and make sure it got this name. So when I reference that name, I can pull that data. So that's basically what a variable does. All right, that's what it is. Notice variables in the program 1-1 have names that reflect the purpose. Now that's not a given. You don't have to make your program run, but I would tell you when you're declaring or designing a program and you're creating variables, especially when you have a large program and you got 50 to 100 different variables in that program, all right, it becomes very important that you give meaningful names to your variables. Give you an example. We can use this example. When we look at what is the statement here? You got right here. When we look at this statement, we created a variable. Well, the program created a variable called hours, created a variable called rate. All right. So now, when I look at this and I read this, pay equal hours time rate. Okay. Even though I don't know what it will rate, is still vague, and hours is kind of vague because I could have put double hours underscore worked and double underscore pay underscore rate. So all of a sudden now when I write my code to calculate my pay, I could say pay equals hours worked time pay rate. And it's like you got that English-like understanding rather than say, because somebody could have put Y equal X time Z. And you're looking at this, okay, Y equal X times Z. It's not as clear as pay equals hours rate, hours work time pay rate. You understand? So that's the only difference. Is it wrong? No, it's not wrong. But at the same time, you want to make write your program to where if you ever have to come back to it, your learning curve is not as you can reduce the learning curve so that you can get to the root of the problem and fix it or upgrade it to where you need it to be. All right, rather than why use that variable? Let me go through my code. This does this, this does that. Why am I using a variable called X? What am I doing with X? And all of a sudden now you're trying to figure out what's going on in your program. All right. But like I say, it's not wrong to do it. But like I say, it can get more cumbersome. All right. And then the punctuation, it talks about the different punctuation in the program. And like I said here, we know where we need to put double quotes, and then certain statements don't have the double quotes. All right. Now, then like I said, we got comments. We talked about the comments, the variable name is stored. That's what we were. Variable names are stored, and you can always retrieve the data stored at that location. All right. Now, and if I change, I could say int x equal 5. So I have an allocated space where x is equal to 5. Being that it's a variable, I could later on say not int, because x is already allocated. I could say x equals to 100, semicolon. And what it does, it overwrites the 5 in that memory address with 100. Okay? So that's what variables are used for, so that data can change. And like I said, you can write code to where data can change and not just stay one thing always. And now you got 100 variables to try to solve a situation because I can't overwrite whatever. So I got to keep writing new functions or create new variables each time so I can accomplish what I need. So, but that, like I say, it eliminates that problem. Variables are symbolic names that represent locations in the computer's RAM, random access memory. When information is stored in a variable, it is actually stored in RAM, okay? It says assume a program has a variable named length, right? So what happens is when it's gonna pick a address, and if you give it a value, it'll store that value at that address. And when you reference length or you type length times 5, it's going to grab that value there and multiply it times 5. All right. But it doesn't change what's in there. It just takes it. Okay. What's there? 72. Okay. Give me 72. and I'll use 72 to do what I have to do, but it's not changing the value of 72 at that address. All right. So variable definitions, okay, in programming, there are two general types of variables. You got numeric variables and you got character variables, right? Numeric variables are numbers are used to perform mathematical operations, and characters are used to print data on the screen or on paper, right? So when you got numeric data, your numeric data can either be integer or float, or well, integer or what's that other word? They use real. It could be float. So it could be a decimal or a whole number, all right? So integer data can be either a decimal or a whole number, all right? So, and they say real. A real number is just a number with a decimal place. That's all it is. So when we say double, hours, pay, and rate, we know we can store data in those three variables that has a decimal place. All right. So now it tells us the word double in this statement indicates that the variables hours, pay rate, I'm going to say pay rate, rate and pay will be used to hold double precision floating point numbers. All right. So that's all it's telling you. All right. And they can say you can use those locations whenever you need to and whatnot. And like I say, the names are all valid, so you won't get an error in the program. Programmers often use the term variable declaration, all right, to mean the same thing as variable definition. All right. Strictly speaking, there is a difference between the two terms. All right. A definition statement, all right, always causes a variable to be created in memory. Now, what that means is if I do int x, it creates that memory location and stores that value. All right. So now, so when I declare it is the variable definition. When I do I'll do int x. Okay, it allocated space for x. All right, at that time. If I do x equal 5, all I'm doing is saying, okay, I want to give X, the value or the memory location. I want to store 5 in that memory location. But the allocation of that variable was done when I did the declaration. So that's basically what they're saying. All right. Because you don't want, if you try to declare a variable more than one time, the same variable, you're going to get an error. All right. And just like trying to go to, if somebody give you an address, say let's say UPS man. The UPS man got 2 packages, right? The 2 packages got the same address, but they supposed to be delivered at 2 different addresses. Can't happen, right? Whatever that address is, both packages gonna have to go there. And what happens, it causes conflict. So if I create a variable with a certain name, all right, it's gonna give it an address. Now, no other variable can have access to that address, but that particular variable that first got it. All right. So that's in the sense what's happening. You know, you cannot have more than one address. So it's like if I go here and I define a variable, I say, okay, I'll just say int num again. All right. I shouldn't be able to do this because what? I've declared the variable num and then I'm doing it again. So it should not, and it's like I'm trying to overwrite in the same space. Let me try to debug that. That's supposed to be an error. See? Oh no. Yeah, see? So I got an error. Right? So let's see, look, int num redefinition. So what happens is it was redefined. So yeah, I got something on C out too. I don't know what happened on that one. Oh, no. Oh, because I took using namespace out. All right. So, but there, it showed that it was redefined, which it can't be done. As I stated earlier, it cannot be done. You cannot redefine at that variable. All right. Now, these are any device, any computerized device should be able to do these three things: input data, process data, and output data. Period. Now it can do maybe be able to do connect to the internet and do some other stuff, but the primary task: input, process, and output. All right. Look at a vending machine. Does a vending machine does it have these three processes involved in it? You input your money. It process how much is put in to determine how much change to get back, or to determine if you can make a selection. All right, that's process. It also, well, that's still process. Then output, when you press a button, it's going to give you the proper selection. And output, it'll give you your proper change. All right. So any device, input, process, output. All right. So input, process, output. That's the three primary activities of a program. All right. So computer programs typically perform these three steps. All right. Now, like I said, it could be other things that you do, but these are the primary steps. All right. CN hour, CN rate, that inputs those values into here. So whatever you input for hours and you hit enter, it takes it. Whatever you input for rate and you hit enter, it takes that. And then it's going to multiply the two together to get a pay, and then you output whatever you have to output. All right. So it just to showing you the process of what a program does. All right. Now, this part here, it can be done several ways at several times and whatnot. And then we close to the end of the program. We got about 2 minutes of class. But what happens is it here? Oh yeah, yeah. In designing a program, class, I know many times you in these classes, you're just starting to learn how to code. They're small programs, so it's like, oh, do that, get it done, and that's all they want. That's all I'm gonna give them. But really, when you get out in the workforce, you will have to document your work, and if not for you, the company, for yourself. And what I mean by that is, you could write code today, right? It works perfect. Everything's going on, whatever. You done got another project you worked on, another project you worked on. All of a sudden, the boss calls you back in and say, "Hey, remember that the assignment such and such and such or program we did? We need to do some updates on it." Now, all of a sudden, if you didn't comment it right, or you don't have the proper documentation created to go along with the program, the design, and all how it was created, whatever. All of a sudden now you're gonna have to go back to ground zero, look through the program line by line to figure out what, how, why, whatever, and which can take you more time than having a document to read and look through. Oh, this is they did it. Oh, this is why this that. Oh, this is that. And so you got a guide basically of what you did and why you did it, so that you can always come back and reference it to modify your program in a more quicker and a more efficient way. All right. Because and even in the documentation, it could have information about why you didn't go a certain route, So that'll eliminate you from trying to do something that you knew you couldn't do the first time. Right. So in creating a program, and just like normally, hey, you're gonna define what the program is to do. So all of a sudden, what now? You need to sit down, and because many times what people do is just get to the computer and start typing, or they start typing, and then all of a sudden they gotta wipe it out, start typing again. But what it's saying, if you can sit down, organize the steps in which you want to follow, whether you're going to use functions, whether you're going to the naming scheme, for your variables or whatever, and get all that set in stone. It'll make it much easier when you start typing. You have some of your documentation already down, and so it make it much easier to work with the program. All right. So these are just some steps, and like I say, you're gonna be going through these steps. Defining the problem. All right, writing out the algorithm, coming there, typing in the code. Oh, code, I got errors. Go back, fix that error, go back through, compile it, see what's wrong, anything wrong, run it again. Sometimes you won't get errors, but what? Logically, you got an error, or visually, you got an error. Example, if your boss says, I want you to take this data, whatever data it is, it got some names in it, and I want you to output the names by last name. Whenever you output the names, last name, comma, space, first name. All right. So you done designed the program, you done ran the program, everything worked perfect. All right, you think. And then somebody said, well, wait a minute, the names are displayed wrong. You need to go back and do last name, comma, first name, rather than first name, last name. All right. So now what? Your program ran. Your program even didn't give you any errors. But what? The output is not what was asked. All right. So what? Now that's not a syntax error, which means, I missed the semicolon, I missed a parentheses or curly brace. No, I have a logical error. The program is running. The program is giving me output, but it's not giving me the proper output, the way in which the output was specified to be. All right. So, class, I'll stop here. And we got these 2 pages. They just talk about hierarchy chart. Your hierarchy chart, that's dealing with functions, which we'll get into later on in the chapter, but it's showing you how you can break a program down into small little segments and then piece it together so that it'll work. So basically, that's all they're telling you in that part. Engineering side, that's the part of doing the research, putting it together, designing it, debugging it, testing it, modifying it, all that. All right, that's the engineering part. All right, and it says procedural and object oriented. Right now we're doing procedural, okay? We just going through the steps, and when we're gonna get to module, we do the modules. But then when you get to 194, that's when you're gonna deal with object oriented. All right. So here modules, we never got them to yet, the functions, but we're gonna be getting to them. So that's what they're saying. That's how we're gonna be doing this. All right. So class, your test gonna be posted at about 2:00. What else? To make sure you do your quizzes or whatever, and make sure you do that variable quiz. All right. Any questions?
This is all, Professor. This is all due next week, correct? Or next
Yeah,
Monday?
by Monday. Well, not everything. The quizzes I think are due by Sunday, if I'm not mistaken. Monday or Sunday. I don't know. Yeah, but the test is the last thing you're gonna take. Yeah. So yeah. So let me see something. Let me go to because if you look at them, if you go when you go to modules, it'll always tell you the end date. If it's let's see, here we go. What a quiz. The quiz, see the quiz. Oh yeah, by the first. Well, this variable name, yeah, that one due by Monday. This one due by Sunday. You see, yeah, this one and this one. Well, don't just this one due by Sunday.
Okay.
And I think the solar learn is due by the next week, not this week coming, but the next week, the next Monday. But don't wait. Just
Yes,
do
sir.
a little bit at a time, and you'll get it. All right.
Yes, sir. Seems like it's gonna be great practice too. I'm kind of excited for it.
Oh, okay, yeah. And like I say, try to get your program. This is what I tell students. Don't write your code. Oh, and when a lot of students wait till the last minute. That's why they caught up. Because if you don't wait till the last minute, more often than not, you're gonna figure out, oh no, this, that, and the other.
Mhm.
And you got time and you're not pressured. Or you'll shoot me an email and I can guide you. But what happens, students wait till the last minute and they submit something, and then when I grade it and give them a 0 because they submitted something with errors in it, it's like, oh, well, Mr. Vester, I could redo it and send it back to you. No. You understand?
Yeah.
I could see if I just gave it to you right there in class to do, turn it in, then give you an extra opportunity. But I give you days to work on it. You know what I'm saying? So when you got days to work on something, you can do research to find a question or reach out, to say, hey, look, I'm having this error. Where's my error coming from? I might not tell you where the error coming from. I might say, okay, look at line so and so, or check. Remember we talked about this, that, and the other. You understand? And
Yes,
so
sir.
then you look at that and whatever. Just don't wait till the last minute, because that's not computer science. Last minute, that's not computer science, because it's too much to do all in one night. You can't do it. When your computer falls down with a virus and you know you got work to do, you can't wait till your assignment is due to say, well, I'm gonna get the virus cleared. You got to work on it till what? You get it done, right? And that's just the way the computer world is, man. It's like, and then some days you might not accomplish nothing, but accomplishing nothing in terms of getting your problem fixed, as opposed to you done accomplish learning certain little ins and outs of what you need to do and what don't do. You got what I'm saying? So when you figure you're not accomplishing, sometimes you really are accomplishing. You know what I'm saying? So try to work on it. And like I say, don't beat yourself up now. Don't beat yourself up and say, oh, I got to do it today and get it done. No, just take your time, work at it. Try to have fun. Don't be in class stressed out. I don't want you stressed out. Try to be lax, learning and doing and asking questions and whatever. Don't stress. Don't stress out on it. All right.
Yes, sir. Thank you,
All right.
Professor.
All right. So y'all have a good one.
You too, Professor.
All
See
right.
you next week.
Yeah. All right. See, take my test now.
Yes, sir. I will.
All right. Bye-bye.
Bye.